Welcome back. In this video, we're tackling question 4 from our SQL practice series, how to combine two related tables using a SQL Join statement. Let's look at our two tables, employees and departments. The employees table stores basic details about each employee, including their salary and the department they belong to. Employee ID is the primary key of this table. The departments table maps each department ID to its department name, like sales, HR, or administration. Our goal is to write a SQL query that returns employee ID, name, age, salary, department ID, department name, in any order. Here's a sample of the input data. And here's the expected output. As you can see, we're combining each employee's info with their corresponding department name. To achieve this, we'll use an inner join to combine both tables on the department ID column. Let's write the SQL query. Here, we're selecting the required columns from both tables, using table aliases E for employees and D for departments to make the query cleaner, and joining the tables where the department ID matches. Let's run the query, and we get 50 rows in the result, just as expected. This is a perfect example of how inner join helps us combine data across related tables efficiently. Let's move on to question 5, how to identify managers with at least 4 direct reports using SQL. We're working with a single table called employees. Let's take a quick look at its structure. Each row of the employees table gives us an employee's details, including who their manager is. If manager ID is null, the employee has no manager. Also, no one manages themselves, meaning an employee's manager ID is never the same as their employee ID. Our task, find the names of employees who manage at least 4 other employees. In other words, they have 4 or more direct reports. The result can be in any order. Here's a sample of the employees table with some test data. In this case, Nina Kocher manages 5 employees, so we expect to see her name in the result. To solve this, we'll use a self-join, joining the employees table to itself to match each manager with their direct reports. Here's the SQL query to solve this. A represents the manager. B represents the direct reports. We join them where A.employee ID equals B.manager ID. Then we group by the manager's name and use having count to filter for managers with 4 or more reports. Now let's run the query, and we get 9 rows in the result. We can see Nina Kocher, who manages 5 employees, is in the result, just as expected. So there you have it. By joining the table to itself and using group by with having, we can easily identify managers with a specific number of direct reports. Now let's see question 6, how to find customers who didn't make any purchases in 2024. Let's jump right into it. We are working with 2 tables, customers and orders. The customers table contains contact information for each customer. Customer number is the unique ID. The orders table tracks each purchase, but it doesn't have a primary key. Customer number here links each order back to a customer. Our task is to find customers who didn't make any purchases in 2024 and return their customer number, first and last name, phone, email. Here's a snippet of the input data. From this data, only 2 customers, Sabalch Kovacs and Ryan Ketchum, had no orders in 2024, so we expect them in our result. To solve this, we'll use a left join to connect customers with orders but only match orders from the year 2024. Then we filter where no matching order was found. Here's the query. Here's what's happening. We join customers with orders from only 2024. Then we check where there is no matching order, meaning order date is null, which tells us the customer made no purchase in 2024. Let's run the query, and we get 73 rows. This means 73 customers did not make any purchase in 2024. And that's how you use a left join to isolate customers without activity in a specific time frame, a common task in business reporting and marketing campaigns. Now let's see question 7, how to find products that had no sales between 2022 and 2024. We'll walk through the problem setup, explore the logic, and demonstrate the solution live in SQL Server Management Studio. We're working with 2 tables, products and orders. The products table stores information about each product, including product number, part number, SKU description, and price. The orders table logs individual sales orders containing the product number, part number, and the date the order was placed. The combination of product number and part number is unique in the products table. Our task: find all products that had no sales from the year 2022 through 2024. We need to return 4 columns: product number, part number, SKU description, and price. Here's a sample of the input data. We can see the highlighted products do not appear in the order table. Therefore, they are the products that had no sales in the expected output table. Let's walk through the SQL query step by step. We start with a select statement pulling the required columns from the products table. We use a left join to match each product to the orders table using both product number and part number. But here's the twist: we only consider orders within the date range from January 1st, 2022 to December 31st, 2024. Finally, we add a where clause to find the rows where no matching order was found. That's when order date is null. Let's execute this query in SSMS and see the results. Here we go. The query returns 11,810 products that had no sales between 2022 and 2024. That's a powerful way to identify inactive inventory, optimize stock, and inform your sales strategy. Alternatively, we can use a not exist subquery, which is often faster and more efficient than left join, especially when the orders table is large. There are indexes on product number, part number, and order date. Why is it faster? Because SQL Server can short-circuit the not exists check. Once it finds a matching order, it stops scanning. In contrast, a left join brings in all potential matches and then filters them, which adds overhead. Executing this query shows a notable performance gain. While the left join method takes approximately 3 seconds to run, the not exists version completes in just 1 second, effectively reducing the execution time by 67%. To recap, we first used a left join with a conditional where clause to identify products that had no orders during a specific time frame. As an alternative, we also explored a not exist subquery, which achieves the same result but can offer better performance, especially on larger datasets. Both approaches are valuable tools for sales analysis, inventory management, and business reporting.